to start in couple of minutes. I think Adita, you can start.
Yes. My screen is visible?
Yeah.
Yes. So, very good morning to all the EKLS members, all the participants. Our today's speaker, architect Rahul Srikhande. So today is our 12th EKLS session. We have started in last year and we have completed 11 sessions. So today is last session of the complete year. And we again welcome all the EKLS members, all the participants and speaker to today's session, which is on approach to carbon neutral and carbon negative buildings through passive architectural design. So now I hand it over to our senior EKLS member, who is Shri Ashok Kulkarni, to take it over and give introduction to our speaker. Thank you. Over to you, sir.
Thank you, Dr. Smita. So friends, on behalf of EKL, Prerana Energy, and all of you, we are welcoming Sri Rahul Srikhandeji. Basically, he's a principal consultant with his own firm, and he's also presently working as assistant professor with two of the college, that is Vivekananda College of Architectures and our Pune-based college, that is Bharatiya Vidyapeeth. So I will just give you the brief background. Architecture Rahul Srikhande, he has done his master's MArch in sustainable architectures. Then he did his postgraduate in business management, project management in the building construction. He is also a Griha Evaluator 2019 batch. Basically, Rahul has done his master's in business sustainable architectures, and he's working in this field of green building since more than 15 years now. Prior to start his own business in 2016, which is Rahul Srikhande and Associates at Mumbai. He was working with Terry, New Delhi, as a research associates in the area of specialization, solar passive architectures, and low energy and high performance building materials. Rahul has been instrumental in facilitating some of the most prestigious projects which was built by government, that is Indian Institute of Campus, educational campus, then various public sector units, banks, and few more in the private segments. Rahul Srikhande and Associate is his own firm, which was established in 2016. And he is also a Graha faculty and impanel member as a technical expert. His firm has owned the last 3 years, that is the Graha Exemplary Performance Award, as our chairman mentioned, 2017, 2019, and last year, that is 2023. Rahul is actively involved in the capacity building, various training programs organized by on the field of green building, organized by the government, various associations, private organizations. And he has also trained several government employees, participations in various organizations. He was also associated with MTech students at Terry University, and presently he's working as assistant professor at the two of the university, that is Vivekananda Education Society's College of Architectures, Mumbai, and the Bharatiya Vidyapeeth, Pune. So with this small background, I would request, we are welcoming on behalf all of you. I'm welcoming Rahul Srikhandeji for our 12th program, and I'm requesting you to take over this. Over to Rahulji.
Thank you, sir, for such wonderful introduction. Hello, everyone, and good morning. Um, I'm really glad to. I just request everyone to keep their Zoom on mute. It would be great because there are n number of disturbances. So just share my screen. Just give me 2 minutes. I'm just sharing my screen.
Sure.
Are you able to see this presentation slide?
No.
Just now.
Not yet.
Oh, just give me 2 minutes.
If you want, I can share the screen.
Yeah. I'll just make this PPT to.
Ali?
Shall I make this?
Screen is still not visible. I have PDF of your presentation.
Yeah, I have a PDF. Okay. Can you just share it and I'll stop.
Yeah. Is my screen visible? Is my screen visible? Rahul, are you there?
Rahul is not seen.
He probably is rejoining.
He's rejoining. Okay. This is what happens. Sometimes this connectivity and the reception, becomes a problem. So I request everyone to bear. Yeah.
Can you hear me, sir? Okay. Hello, everyone. I just request just to mute. Would be a great help for me as well. Great. So, sir have given me a wonderful introduction. Thank you, everyone, for joining this meeting, and thanks to Gande sir for inviting me for this and giving me this wonderful platform to deliver my thoughts. So let's start begin with this. If you have, I just want to tell you, if you have any doubts, you can stop me in between and you can ask because I don't want to be a one-way presentation. I want it to be a interactive session. So if where you have doubts, you can raise your doubts, unmute yourself, and you can ask the question. Okay. So today we are talking about the approach to carbon neutral and carbon negative buildings through passive architecture. um, that's the passive architecture is where I have my specialization. So using that skill, my approach towards the carbon neutral and carbon negative, it's a bit different uh, than the general one. So let's begin with this. Ma'am, can you next slide? Next slide. Okay. So this is a table of content. These are where we talk about the net zero or carbon neutral, what exactly it is, what are the problems, then where are the solution. Then there will be a comparative between a passive architecturally designed building and a net zero or a carbon neutral building. And then there are the carbon negative building. We have some case studies, and then the two benefits, and there I will be sharing two case studies of my project where we have approached towards the carbon neutral buildings, and we can share look at how we have approached towards the designing and then to achieve the carbon neutrality. Next. Okay. So to achieve carbon neutral and carbon neutrality by 2070, that's what is the target set by the government, that all the buildings, everything what we are consuming today has to be net zero or a carbon neutral building by 2070. But then how? And with the help of what? Just the renewable energy? Yes, the renewable energy is the great boon, but that just by using renewable energy, it won't meet. You need to uh, balance out the demand and supply. So the the word passive architectures come in picture, that you have to reduce the demand and then the supply, the renewable energy, that's where we have to intervene. So the carbon neutral will be very easy if we balance out this demand and the supply side. So instead of burning fossil fuels which emits more carbon, energy generated by renewable energy sources can be used in every building. But how much energy can be generated in a building? So in a city where you have a low rise building with a low density, so you have a larger roof area as compared to the total built form. There the requirement can be more fulfilled through renewable energy on your rooftop itself, because you have a percentage wise, you have a large number of roof area. However, in a city like Mumbai where we are actually working, so it is very difficult to install your all renewable energy, um, the capacity required by the building. It's extremely difficult because the buildings are very high, the built up area is very high, and then the roof area is very small. Okay, so it is very difficult to meet the requirement of the buildings renewable energy demand. Almost 30 to 50% of the annual energy consumption of an entire building could be offset with the help of renewable energy. Today, yes, we have certain examples where the almost 100% of the building is also meeting the requirement, but averagely 30 to 50% is what we have working on. So whatever Griha project we are doing on, so 30 to 50% is the average where we can meet the building's demand. Okay. So, and but to achieve net zero, we need to offset 100% of annual energy consumption, which is very impossible, and which is only possible through the offsite renewable energy. On-site, you can't. It is not possible in most of the cases. as it requires a lot of space and cost to install a renewable energy system for the amount of energy generated, which is not possible for every building. So there's a cost aspect as well as the space aspect. As I mentioned earlier, the ratio of roof to the built-up area matters a lot. To achieve carbon neutrality, we need to add 100% of the carbon emission. Right. So achieving carbon neutrality is something 100% of carbon emission need to be offsetted. Can we offset 100%? Yes, we can offset 100%, but there are certain problems. And what are those problems? We can discuss that now. Next. So how are the building built? So today the buildings are, I know there are n number of cases where the architect have designed building, and then in between somewhere during the construction, the client or the architect realizes, okay, let's go for green, let's go for green building technology, and then they intervene. Green building consultants where they are asking ki, let we want to make this building a green building. It can be possible by using what you say high performance systems or the technologies. Okay, but it is not possible to make that building a carbon neutral or a carbon positive building or a 100% carbon neutral building, because the systems only the systems can't help you to make it net zero, but it will definitely reduce the energy consumption. But the building envelope, the building roof, or the building orientation, everything is poorly designed. So automatically the need of the energy is very high, and then you are adding, so the your energy consumption is very high. Say from 100, it has gone to 150 EPI, and then you are saying we are offsetting 18. So that is not a big deal. So if you have designed 100 EPI building and then you are offsetting 80, that will make a huge difference. But you have designed a bad building whose EPI is 150, and then you are saying if we are uh, offsetting 70 or 80, then that's not the real uh, what you are saying, the green approach. Okay, so and that's what we are facing, the general practice in the country now, that the people are like not designing the building for the climate context, but they're building something else, and then they are trying to intervene all the green features into it. So what are the causes to increase demand of electricity in HVAC system? So the buildings, so what are the problems what we have discussed? So the buildings with no daylighting, the building with no ventilation system properly designed, the building with wrongly orientation, the building which are having east west elongated surfaces. So this type of buildings designing will make a huge impact on the building energy demand itself. So how is the energy usage effect? Because of the no lighting, daylighting, uh, you have to use the artificial lighting system during the daytime also, and not using the naturally available abundant free source of light. Because of the wrong orientation, the building, and the wrong selection of material as well, especially the glass, the building will have tremendous amount of heat gain. That will also create a huge impact on the energy demand, because for the HVAC system. So these are the issues, and this affects a lot on the energy demand itself. So what is the environmental impact? A high energy use in building leads to increased greenhouse emissions, air pollution, resource depletion, global warming, and climate change. So a building, not just by using the high performance systems, but you have to use the common site context or the climate context consciously designed building will help these problems, and how we will discuss that as well. Okay, next. So the solutions, there are very simple solutions which are graphically represented here, that can be easily introduced into the architectural design by an architect. But right now on this platform, I'm sure there are almost 90%, 99, 95% the audience are engineers. So I will request you all. So if you are working on any of the project, so you should demand your architect that you need to go for the passive design strategies first, and then let's optimize the energy and the systems. That will save a lot of sizing of the system as well as the costing of the system. So how to be, how the building should be designed to enhance the architectural design approach. So by using the passive architecture features. So one is extremely important is the orientation of the building. The building orientation towards, say, in our climatic context, the north and the south surfaces receive very less amount of radiations, and whatever radiation what falling on the north and south can be easily tackled through shading devices. However, the east and west facades are extremely difficult to tackle with the solar radiation falling on that. To optimize the shading devices is also difficult on east and west facade, and the radiation, the quantum of heat coming from east and west is also very high. So the orientation of the building itself plays a major role. Then the placement of the rooms. So whatever rooms you have, habitable spaces that has to be on north and south facing, having larger windows, whereas the east and west should be completely blocked by using, say, all the buffer spaces or non-habitable spaces like toilet, staircase blocks, storerooms, anything which is non-habitable spaces, that such rooms can be easily installed or placed towards the east and west. Second is introduction to the daylighting system. A good daylight building can reduce a good amount of energy consumption to a building, and can also give you a good ambience as well as a good healthier building for the end users. A good daylighting can be achieved by using again the properly oriented, properly sized, optimizely used glass specification for VLT and SHGC. What people usually feel like a glass building, completely glass building, will have a good amount of daylight, but that's not the case. A building with completely glass will give you a glare, not a diffuse light. What we are expecting is a diffuse bounce back light, which is very helpful to us. If you are getting a glare or a direct radiation coming into the building, that's the case in all the glass building. So what you will do, you will put on all the blinds, and then again you will find oh, it's dark. Now let's put on the artificial light. So even though you have a complete glass building, what people do is put on all the artificial blinds and then go on the artificial lighting system. So you're again consuming energy for lighting as well as introducing heat and adding more load on the HVAC system as well. Second is the naturally ventilated. Try to meet passive cooling system or a naturally ventilated building wherever possible. A good ventilated building will not just reduce the energy consumption of the building but also makes a healthier building. A fresh air is always better than the air conditioned air. And the passive heating and the cooling systems, that's what we will talk about. That's the only approach to reduce your building energy demand 100%. um, by using such as passive strategies such as earth tube cooling systems, stack ventilations. Such strategies can be easily introduced. So this is what we have already discussed. So the building orientation, which refers to positioning of the site and considering the vegetation and the surrounding building. Surrounding building will also help you to optimize the energy consumption. Second is the daylighting, what we have talked about. Third, next, next, naturally ventilated we talked about, and then the passive heating and the cooling system. So this passive heating and cooling will play a major role because the word passive, that is naturally, by using the basic science of heat transfer, what we have learned in the smaller classes right from the 7th, 8th standard. The principle of heat transfer plays a major role in meeting the passive architectural buildings. And I'm sadly saying this, that there are no syllabus of heat transfer in all our 5 years of syllabus, like whatever syllabus we have for architecture, the 5 years curriculum, we don't have this particular heat transfer sessions in any of the subject. And I believe that this is the most important thing for an architecture student to understand the heat transfer, at least with respect to the ventilation, is extremely important, so that an architect can also reduce completely the energy demand of the building. Next. Next. The previous one. So we talked about the stack ventilation. This also plays a major role based on the science. The stack ventilation is basically to remove all the hot air from your spaces. So what we have learned in seventh is that the hot air rises up because of the lesser density. It rises up and the cold air sinks. So stack ventilation is nothing but it's a high level chimney from where you can removing your all the hot air from your spaces to this space, and the naturally the draft of the cool breeze coming from the lower height of the windows. So this is nothing but it's a creation of the draft, and this is also working where you don't have a breeze, or there's absolutely a calm condition, there is no breeze, but the stack ventilation will help you to create that draft of the air inside your spaces. Okay, so just by understanding the basic principle of heat transfer can change the entire spaces very positively. A tube cooling system we will talk in detail. Evaporative cooling system is also we will discuss in detail. Next. The material selection. So the building materials, I believe the extremely important part of the any building designing is the envelope of the building, and the building envelope plays a major role, which has walls, roof, and the glass. These are the three major materials where most of the people really don't bother about. So it's architecture is all about. I'm saying sadly saying that 95% of the architecture people who are practicing, they all are fascinated about the aesthetics and the looks of the building, which is not wrong. But if we add a little bit of science to it, again the principle of heat transfer, what material we are using, in what climatic condition, the site context, if we connect all these three things, then the building will run very like phenomenally. Because if we are reducing the heat transfer through building envelope, which will help to reduce directly this 50 to 60% of the your building energy demand. It reduces directly your building heat gain, and definitely reduces your cooling demand of the building, cooling or heating demand of the building. Okay, so in India, today also the most commonly material used is the red brick. However, I have also published a research paper on comparative analysis of various building materials used only for the walling systems in India, right from the red brick comparing to all other CLC blocks, fly blocks, AC blocks, hollow concrete blocks, CBSE blocks. So it is found that the AAC block is one of the most efficient and the best suitable material. AAC is aerated concrete blocks. They are the most suitable blocks or the walling systems which can be used in India very effectively, because it has a very low thermal conductivity. Two, it is made up of fly ash, which is almost 50 to 70% is the fly ash ratio, which is environmentally benefited. Third, it is lighter in weight, almost one third the weight of the brick. So it reduces the building dead load. Okay, the load of the brick is reduced, so the dead load of the building is reduced. Then the automatically your structure system, which is RCC, and the steel, the complete steel and concrete is been reduced because the dead load itself has been reduced. So you save a lot in steel as well as concrete as well, which are the which is the highest amount of embodied energy consumed material in building, entire building. which is the steel and the cement concrete. Okay, just by placing or selection of a right material, which is replacing your red bricks with AC block, can benefit you at a so many tangents, not just the building operational energy, but also optimizes your building structure system. It reduces the load, so your columns and beams also reduces in the number of or the sizes as well. So this selection of right material plays a major role in building it. Next. So what is the difference between a not poorly I will say, but a generally architectural practice design building and a passive architectural building? We can compare this two things. The first one is the conventional building, let's say, a relief heavy on mechanically heating and cooling system. So this conventional building directly has a huge what do you say, the dependency on the mechanical heating and cooling system. If it fails, the people in a glass building can't survive. So just imagine a glass cube building in any Pune or a Mumbai BKC area. The air conditioning system fails for 2 years, or 2 days, not 2 years, 2 days. So the building won't run. It will completely shut. However, if you have a passively designed, it don't require air conditioning system. So there is no such what you say the situation will occur where the building may have to shut down for 2 or 3 days. But the passively designed will directly reduce your mechanical energy system sizing as well as the energy consumption as well. Okay. The second one is the low performance windows contribute to heat loss in winters and heat gain in the building. So the low performance, or the if you have a single glass window, so the building the glass will have good amount of heat gain and heat loss, which will directly impact on HVAC system. However, in a passive architectural design building system, we always try to have a properly orientation and a properly optimized size of the building. The word optimization plays a major role in this, along with the shading devices. And then the high performance glass needs to be introduced or not. Even a single clear glass with a proper shading device can reduce this tremendous amount of heat gain into the building. Third is high energy bills due to excessive energy consumption. In a conventional building, you have to pay a lot on energy bills. However, in passive design building, the energy bills are really it reduces your energy consumption. It saves directly on the money. The conventional building designs are contributing towards the greenhouse gas emission and air pollution. However, in passive design, this it reduces the environmental impact in all the tangential, whatever tangent you will call about the environmental benefits in all the tangents. It's a boon. The passively architectural design buildings are the boon to the environment. um, Occupant discomfort, yes, sometimes there's an n number of discomforts occurs visually, acoustically, thermally in a conventional building. However, it enhance not just the comfort but the overall health benefits to the end user as well. The health benefit respectively your mental health, your physical health. The passive design building, because there's a good amount of daylighting, you are always connected to the surrounding environment, which will also make you feel better and make you feel fresh as well. The productivity in offices are really seen very high in passive design building systems. So the possible energy consumption um, offset by using renewable energy in a conventional building is 50 to 60%, not 30 to 50, but at least 50% can be easily done. But however, if a passively designed building is there, you can directly go up to the 100% optimized building, 100% carbon neutral building by using passive design. Next. So carbon negative. There are steps to carbon negative. So there will be carbon neutral, then there will be net zero, and then the carbon negative building. So the approach to carbon negativity, so one, you need to be a carbon neutral by using step one is to CO2 emissions from built environment is comparatively absorbed by the trees and plantation. Okay. Second, cutting down the CO2 emission from burning fossil fuel by using renewable energy sources. And third is, since CO2 emission is cut down, the CO2 absorption exceeds the generation rate. So if you are offsetting the 100% of CO2 emissions, then the carbon negative building can be possible. So these are the three ways which we will discuss in detail now. Okay, next. Benefits. So there are environmental benefit, economical benefit, and the social benefit. So environmentally, you can reduce the carbon CO2 emission, conservation of natural resources, and mitigation of climate change can also be optimized or reduced in by having such approach. Economical benefit, yes, it reduces your energy bills. It increase the property value. Yes, if you are staying in a green building or carbon neutral, automatically the market value or the prestige to that particular project has really boost up, and that helps the builders to increase the cost per square feet of that property, and potential for government incentives and rebates. So government has tremendous amount of schemes and facility for such type of building, which helps to get maximum benefits and gives you many rebates, as well as the property tax benefits as well. There are, you can save a lot on money. And there are social benefits. It improves the indoor air quality, enhances occupant comfort, and promotes promotion of sustainable living practices, is also helping to maintain the harmony in the society. So these are the three benefits of carbon neutral building, which are environmental, economical, and social benefits. Next. So what we'll do, we'll go through the case studies. So I will be introducing two of our projects. So this is a memorial for Balasaheb Thackeray. This is based in Badlapur. So the site area is for only for the construction area of this building. So the entire site is almost 25 acres. However, just to we have subletted the right, so smaller piece of chunk of that entire land, which is almost 3,000 square meter of the area for the construction. Rest entire site is conserved with uh, trees. It is preserved for all the existing trees, and we have planted more than 20,000 trees now. I will show you the previous historical images, Google Earth images, as well as the latest images. It's a okay. So this is the complete site. What you see in the left. So on the left hand, the number 1, 2, 3 is there. So that's the upper road, and the 4 number is there. So that's the lower road. So I have a slope of almost 80 meters. If you can see this image 4, so which is clicked from the lower road, and that's the site. We have a steep slope of 80 to 100 meters of the contours we have. That's the height of the site. So what we did, we placed the building towards this 1, 2, 3 area, and the rest entire site what we have done is the preserve with existing trees, and we made a nature trail for the people so that people can walk, hike on this mountain, um, um, without without using any single cement or any aggregate or any man-made material. What we have done is we have using the contours and cut fill with the existing soil itself, and by using the stones we punch it and made a 3 feet 2.5 feet wider pathway for people to walk on this entire mountain. So it's like more of like a nature trail uh, for the people, so that they can be into the nature, and at least 2 kilometer walk is there in this 25 acres. Secondly, now the site is home to n number of species. So you can see tremendous amount of butterflies, uh, different birds coming in here now, and that's adding a lot to the environment. And this is like a small forest inside our city, which is Badlapur. And then the small we what we did, we don't want to impact on the site by constructing any building in the visuals. So what we did, ma'am, can you go on the previous slide? Okay. So if you see, so from the upper road, if you see, there will be only the garden. So the entire roof is garden, and the structure is earthbound. So the only on from road level, the structure is only 600 above. So it's just 2 feet above the road level. Rest the entire building is earthbound. So that helping me to merge the structure with the completely landscape, surrounding landscape. And the earthbombing helped me to completely ignore the heat gain from the three sides of the structure, and only the one side which is facing towards the valley having the windows. Okay, rest entire structure is completely earthbound. So one thing is, we are not I don't want to disturb the harmony of the site which is completely green by adding a structure, but just merging the entire structure into the landscape. And the memorial, the three towers are only there that symbolize the Shiv Sena, that has a different logic to it. So that symbolize the Shiv Sena and Bala Sahib Thackeray's thoughts. So these are the three pillars which symbolize the Shiv Sena, and the dome below that, what you can see is a space for worship, where we have a idol of Bala Sahib Thackeray, which is 1:1 scale, which is below that dome and the three columns. Next, next, next. So if you can see the previous one, ma'am. Okay, if you can see this, the structure is very small, whereas the gray is the contours what we have made, the smaller pathways on the entire contours, and then the a good amount of plantation has been there. There was a small, extremely small stream, which is a perennial stream, which is flowing throughout all the 12 months. So what we did initially, from so many years, the water was just flowing through the site and going to the Nala, which is just next to the site. But now what we did, we have introduced three small check dams. You can see this three pins reservoir where we have written. So there are three check dams which helps to slow down the flow of the water and helps water to be getting percolated inside the mother earth, as well as the same water which is stored into this dam is used, what we have used this for the irrigation system as well, for the entire 25 acres. Yes, that's not sufficient for us, but whatever available water is available, we are using that water for the irrigation system. But it's a matter of 2 3 years. Once the trees are matured enough and self-sustainable for its own water demand, we don't have to water. And now it's almost, we are reached to that stage where we are completing almost 3 years to this project for the tree plantation. So it's almost there. So the water is now as a feature which is following three steps, and what we have introducing now is the completely lotus ponds. We are planting lotus to these three ponds. Next. So on this previous slide, ma'am, if you see this 4 number image on the right top corner, you can see the site. It's completely green. The structure is merged with the surrounding trees. On the image 5, so that's the entry to the building. If you see, so the building which are below are 7 8 story, which are below your eye level. So the structure is at a very high level. Next. So if you can see in the section, the structure is completely earth bumped, And the use of contours plays a extreme role without cutting any trees. The use of contour is been done, and this contours helps me to meet all my requirements of passive features, of reducing the heat as well as going with the harmony of the nature. Okay, and then what we have introduced is small skylights on the art galleries what we have. So if you see the section, there are two skylights which are not on the from the horizontal surface, but the from the sideways what we are getting the daylighting, diffuse daylighting. I guess we have introduced the picture of that rooms as well in coming slides. Next. Yeah. So this section is showing you the light coming inside the yellow part. The light is coming from the uh, skylights, which are the side lights from the roof. Next. Okay, these are the actual images. So you can see the light coming inside the spaces. It's completely daylit, but you are not getting a single glare into the building. We have introduced a light shelf as well. You can see on the left top photo, there's a slit of window just bottom to the beam, and there are these two sections on the right. So what we have right now, it is on the top one without the light shelf. So the light is not even coming to the 40% of the room, but uh, we are in a process of installing the light shell, which helps to reflect and bounce back the light towards the deeper spaces of the room as well. So such small strategies helps you to like reduce your energy demand as well. Next, the stream. So this is the section of the site you can see. So there's a small structure on the top of the mountain, and then we have three streams which helps. So the photograph of first stream is also there on the top left corner. You can see a water also. So this helps us to store and conserve and use the natural available water on the site. Okay, next. Energy efficiency, yes, we have used obviously the LED system to we have cassette air conditioning system to the space because of a very small scale of the project. We have used cassette system for all the spaces which are art galleries, libraries, office spaces, canteen, and the prayer hall. And there's a small AV room as well. So we have used such cassette system. Then we have with the help of what you say the design itself, we have reduced 65 almost 66% of the heat gain just by placement of the structure correctly as well as by doing the earth burning. We have reduced 66% of heat gain, and also 66% of the energy consumption from the waste heat has been reduced by using renewable energy as well as the proper efficient systems. Next, solar of so, as per requirement of GRIA, we have just using 2 to 3 kilowatts of solar panels towards the northern side of the site. We have placed the solar panel because on the south side we have this tower, so we don't want to cast the shadow on the panels. So we have placed the panels towards the north side facing on the having the southern slope. Okay, and this installation of solar panel is reducing our demand by 98 almost 99% of the building demand. Next, and these are the 3D images of the structure where we have used all low energy material which are environmentally friendly. We have also used earthen pots for the insulation of the roof. We have inverted the beam so that we can reduce on the cost of the fall ceiling, and size of the height of the building we need to reduce. So what we did, we have inverted all the beams, and to maintain then the yeah, what you say, waterproofing for the landscape and everything. What we did, we put it the inverted earthen pots, and then the filled with the AC blocks, and then screeded with cement, and then the flat roof is achieved. So we can have a air cavity in between the roof section itself. Next, water. Yes, we have the stream itself. All the low flow fixtures are used in the building. STP is been introduced, but we are not recycling and reusing that water because we have meeting the demand of the building, and it is not financially viable to use STP for such a small building where we are not generating a good amount of handsome amount of water to run the STP. Next. Socially, yes, we need to think about the social parameters as well. So what we have is people who are differently able people. So we have all the ramps provided to reach out all the spaces. Uh, then we have toilets for differently able people. We have gazebos for small or small kids. We have garden area. We have gazebos for the senior citizens, a pathway which is completely without any step. What we did is a pathway so that senior citizens people can directly walk, or a wheelchair can also go on. So these are the small things initiatives what we had taken. Next. Okay. So under the Amrit mission, what we did. So if you can see this image, it's the same site in February 2016, February 2019, and February 2021. If you can see the images, so there were very few existing trees available on the site. By 2019, we started planting few trees, and today, by 2021, that's the latest image what I have. If you go to the site today, it's completely green now. So this is 2021 in the month of February. So just see the transition what we made. Under the Amrit mission, what we did, we planted 20,000 local native trees, which attracts birds, which attract different insects. So the whole biodiversity has been created, and this just happened without any thought process. That we just thought that we need to introduce more number of trees, and we need to make this like a breathing lung for the city, um, which gives good amount of oxygen. But then for the competition purpose, we thought of calculating the CO2 emission done by the building and the oxygen produced by the trees. So next slide, ma'am. So what we have achieved that we are producing almost one fifth of carbon emission than what we are producing the oxygen. So almost 20 times more oxygen what we are producing. Um, the entire calculation I've done, and what we have done is six times. So 100% carbon emission is absorbed, and six times the oxygen is being produced. That's what we have achieved in this building by planting so many trees. So this is the next one. So this is the image what you can see. This is what we are expected. This is not yet completed. The all works are going on now. So this is the final expected product what we are seeing. So this building is uh, carbon neutral because the amount of trees what we have planted is absorbing or producing more, absorbing 100% CO2 and producing more oxygen than what the building is producing the CO2. Uh, this happened just because of the space what is available and the efficient use of the space. It's not just the architect was the thought, but even the bureaucrats and the local authority, all the COs, everyone was very keen to have this project on at a national level. We want something, and this project have got the national award last year. in the Griha Summit as a best passive architectural design among almost 100 entries. 78 or 100 entries were there. So among all those entries, this building got the first place. Just hold on. I need to plug in my charger. Great. Next. So this is the Akshay Jyot bungalow. This happened to be in Jagdalpur, Chhattisgarh. It's a very small bungalow, having only 200 square meter of built-up area. Okay, it's a G plus two structure now, um, with no air conditioning system at all, and having a occupancy of like 5-6 people staying in the house. Okay. Jagdalpur is an extremely small district in Bastar area of Chhattisgarh, completely Naxalites. Um, the people over there, they don't believe in having a setbacks areas, that is the marginal setback from boundary. We need to leave some spaces, say 4 feet 5 feet space, at least 4-5 feet space. They construct buildings which are compound to compound, edge to edge of the plot, but it takes me almost 3-4 months to convince my client that we need to leave the space of 3-4 feet from all the sides of the building to enhance the quality of space by introducing daylighting systems. We need a good ventilation and lighting system into the house. And finally, they agreed, and then we started the designing. So this building is also completely 100% passive system. We don't have any air conditioning system to this house, but the entire building is being run on the earth tube cooling system along with stack ventilation. We'll see the designing next. So the orientation. So the orientation of the building, as I said, as I mentioned in earlier slide, it plays a major role. So the building is oriented as per the what you say, site context, as well as the facing most of the windows towards the north, and east is the main facade to the house. So what we did is we have a very small slit windows which are punctured inside the box windows, and the major part of the east facade is covered with the car parking and the porch and the buffer spaces. Whereas north, you can see there is a skylight and there is a turbo fan. There are two turbo fans as well into this house. So that's how the entire structure has been designed, like oriented. Next. So the pink blocks are basically the um, vent as well as the intervention for the daylighting system to the roof. You have a skylight as well as the turbo fan or the stack ventilation is there on that spaces. So the spaces are double height. The pink one, the blue ones highlighted are the buffer spaces from the east facade, and east you can see very small two windows on the living room. So these smaller windows are introduced to cut down the direct radiation coming inside the house. If you can see the first floor plan, so there's a projection out as well as the box or the window has been created so that you're getting the shading devices from sides of the window as well as from the top of the window as well. That cut down the glare coming into the house. Also towards the west, what we have is the toilets and the lift room. And the room having the bedroom, there's no window on the first floor towards the west. It's completely a dead wall, and a small slit windows are introduced towards the north and the south. So this helped me to reduce the heat on in the building itself by placing the windows on a optimized, rightly, correctly placed orientation. Next, ventilation. So because we are having the stack ventilation in this puja area, so the puja room is double height with that turbo fan, having a daylighting as well. So the entire room has been, all the spaces are designed in such a way that all spaces are having two windows, at least two windows, as well as the stack has been centrally placed so that all the hot air can be escaped through the roof itself. Next, next. So the section can be seen. So the puja area with a double height and a turbo fan. So this pulls out all the hot air from the spaces. Next, next slide. Yeah. So what we have used is a earth tube cooling system in this house. So during the plinth level itself, what we have introduced a 9-inch diameter CPVC pipes is been introduced into this structure, which is laid down below the plinth itself. And so there is a one end which is connected towards the, if you can see the side plan, so the pink rectangle on the left bottom corner, what you can see is the inlet to the earth tube cooling, from where the air is been introduced into the earth tube pipe. And then these pipes are traveling almost 70 meters below the plinth level, and this pipe having a inlet or a outlet, sorry, the outlet into the rooms at a various locations, which helps you to get the air from this pipe. So what happens in this earth cooling system, a hot air has been introduced, or the ambient air has been passed through this pipes, but below the earth the temperatures are at least 4 months back the temperature or the average annual temperature of that climate, or of that city. So because of the hot air passing through this pipe, and the surrounding of this pipe is the soil, which is 4 months back the temperature. So what will happen? There will be a heat exchange between the pipe, between the air and the surrounding soil, and the air because the air is traveling almost 70 to 80 meters through this pipe. What will happen? There will be a heat exchange between the air and the soil, and the air becomes cooler, and that cooler air is being passed to the spaces. Okay, so this is what is earth to cooling system, which has been introduced as now. Two, where we have the inlet to the fresh air, we have planted all the seasonal flowering trees, which helps to give the fragrance to the air as well, and oxygen giving tree, a neem tree is being planted now, which helps to purify the air as well as adding a fragrance naturally without using any airwick or air freshener. What we have is the natural flowers planted around this inlet, so that fresh air with fragrance and a good amount of oxygen is being introduced into this pipe. So this helps us to reduce the temperature from almost 36-37 degrees Celsius to 26-27, almost 8 to 10 degree drop has been seen into this house. Next, without using any air conditioning system or any mechanical system. This is completely passive. Even the draft is completely passive by using stack ventilation. But still, for the sake of client, we have introduced a fan, pressure fan, where the air can be blown into the house. Next, next. So the roof is giving me the natural daylighting because of the surrounding. All the three sides, I'm having a house which are 2-3 story high, and I'm just leaving the 2-3 feet of space from this compound walls, which are like the surrounding neighboring house. So I need to introduce a light which is coming from the roof, so that all the spaces should be properly daylit and diffused daylit. So this puja room tower is also placed with the glass, as well as the north facade of the living room is having a double height, where we have a dining area, and a nice natural daylight has been introduced. This roof lights are covered with DGOs so that the heat can also be reduced. Next. So the few photographs. Okay, so the material what we have used is all the AEC blocks, which helps us to reduce like a tremendous amount of embodied energy. Almost 65% of the embodied energy is being reduced just by using the AEC blocks. Next. Next, ma'am. So these are the photographs from the sites. So this is the main entrance, which is the east facade. So what we have used is the jali, which can allow ventilation and also protecting the house from the road. So the right top corner is the balcony on the first floor. The left photo is the slit windows of the eastern facade of the family room. Next. So whatever material we have used in this house is all IGBC or Griha certified material, right from your flooring, your walling materials, glass, uh, plywood, any adhesive sealants, any damn thing. Out of all the 100, 200 materials, whatever has been used in this building, all the single materials are certified material, which are environmentally benefited. Next. So almost 78% of water is being reduced. Water demand is being reduced. 65% of embodied energy, which is through the building materials, is being reduced. Okay, the house is having solar panel. This is what initially we have calculated, that the 70% of energy efficiency is being used, and 89 to 90% of renewable energy what we have offsetting the entire energy whatever we are consuming is almost 90% of the energy demand is supplied through renewable energy. So this 70% reduction in energy consumption helps us to optimize the costing and the sizing of the renewable energy. That's why we are able to offset 90% of renewable energy. If the energy demand was hardly 10-20% reduced, then this the same kV of solar panels would have just met 40-50% of the energy demand. Right? So by using all the passive features, first is to reduce your energy building energy demand, and then automatically your renewable energy sizing will definitely grow. So in previous project also where we have stopped is somewhere around 98 or 97% of renewable energy, this project also we have stopped somewhere around 80-90%, so that to optimize the sizing and the investment for the renewable energy, we are not meeting 100% in both the cases for the renewable energy, but this is the way what we I have that approach, that you should not oversize the renewable energy, because in the months we are where we are producing more renewable energy, so net metering is one of the solution, but still to optimize the cost, uh, I always stop somewhere around 90-95%. This is what I am believing. Next. So this is um, the way I have approached towards my project, and these are because of the time limits and constraint. I am able to show you only the two projects. So there is one more with an earth tube cooling system is in Amritsar. There we have introduced 600 meters long earth to cooling pipes. So there are 6 pipes of 100 meters long. Each pipe is 100-meter long, but there are 6 such pipes of 450 dia, which are hume pipe. In this case, what we have used is the CPVC pipes, but there we have a huge space as well, and that's a huge house, almost 10,000 square feet. So we have introduced completely pipes of having 600 meter. So Amritsar being a composite climate, you have extreme summers and extreme winters. So in winters you have say 2 degrees, 3 degrees, and also it goes in Amritsar. So when you are having 2 degrees or 3 degrees outside temperature, we are able to meet 18 to 19 degrees Celsius inside the house because of the earth tube cooling system is working as a heating system to the house. And in the months of summers, say in June, May and June, where the temperature goes beyond 45, 46 degrees Celsius, at that time we are able to meet 26, 27 degrees Celsius inside the this project, Amritsar project, was completed almost 5 years back, and it is 100% giving all this data was shared by the client. He's uh, he was the ex vice president of Aisha Group, so he is from this background of mechanical engineering and energy optimization. So he has all the devices. So he always measures the outside and inside temperatures and always shares all the photographs of optimized windows. So we design windows in such a way that from 1st of November to 20th of February, all the radiations can come inside the house, and rest of the year, the radiations are just touching to the what you say the sill level of the window and but not entering into the house. So that's the optimization word what I'm saying. So maybe sometime, some other time we can see that case study in detail. And that project also have received uh, exemplary performance award under the solar passive architecture category during 2017 Rias. Mm, thank you everyone. If you have any questions, if you have any doubts, you can ask me definitely.
Sure. Thank you very much. It was indeed very insightful presentation by Rahul. So we have few questions that is coming in our chat. I'll just read them out. What is the cost comparison of various materials?
Various materials. So AC blocks, if you compare, it is cost effective as compared to your red bricks, because in red bricks you require tremendous amount of labors as well, because you have cement, you have sand, everything, and it takes a lot of time to construct as well. The red brick one. Whereas the Siporix blocks are larger in size. It don't require the cement and sand, but it has its own adhesive, which can be simply directly placed. And because of the size of that block and the weight of the block, the construction time is reduced drastically, and it saves a lot of time. If you compare a 10 feet by 10 feet wall, a red brick wall, and a Siporix block wall, so the it is much cheaper than the red brick.
Okay, the next is three things common citizens can explore to support green initiatives.
Pardon?
Three things common citizens can explore to support green initiatives.
Three things that a common people can do. Okay, so a conscious mind, a conscious mind plays a major role. A small initiatives for green lifestyle. Really. Green lifestyle, right from avoiding plastics, having your own clothes bags. I believe it's not rocket science. It's a common sense. For environmental benefit, one need to be very using common senses is, I guess, the primary goal for every citizen. Because for the technical thing, you and me, we are there. But for common citizens, common sense is more important than any other technical knowledge.
Okay. The next question is how to determine at what depth can we place the pipes below ground?
Okay. It is a study. It says that somewhere around 4 meters, you should go below the ground. 4 meters, 3 to 4 meters.
Okay. The next question, with the same background, is how to decide the length of pipes. Like how many? What is it? Are required to cool how many?
So,
Aishwarya, can
okay,
you read the question? Okay. I'm not able to
I
read
got
that
the question.
phrase. Okay.
Okay, I got the question. So basically, the question is how to optimize or determine the length and the size of the pipe. So it has directly connection towards the heat gain of your building, the volume of the space, how much area you need to cool down, and there are a long method of uh, calculating the diameter of the pipe, the length of the pipe, and the velocity of air also plays a major role at what velocity it is at. If the velocity is large, then the pipe length will also increase. If the velocity is reduced, the pipe length will also reduce. If the diameter is more, the core of the air, there won't be any connection with the surrounding soil. So the depth, the diameter of the pipe will also play a major role. So it's a permutation of combination of diameter, velocity, and the length, and the depth of the pipe as well.
Okay. Then there are few comments regarding how excellent the presentation was. And people are congratulating you for handling such a difficult and wonderful subject at the same time. Mr. Sriram is asking, how can the data centers be a sustainable data center as it uses more electrical systems?
Sir, I have worked on the STPI Mohali building. It's a data center, Science Technology Park India Limited. It's a government building built by CPWD. If you look at that building, it's completely a regular glass block building without any passive features. But that project have received uh, ex, exemplary performance award by GRIA for energy management. Um, Obviously, by using small features like orientation and everything, you can reduce the energy demand because of the heat gain reduction. But your data systems, so your system energy itself demand is very high. So you need to go for high performance systems, energy systems. The centralized air conditioning system, what we have used, is very efficient. The introduction to IoTs and the technology was there. All the sensors and what you say that the IT is been introduced very effectively in that building. The building integrated management system was there, and almost 60 or 80 kilowatts of solar panel. The entire roof was covered with solar panel. Even the LMNR room, the lift machine room, was covered with solar panel because the scale. And that building have received exemplary performance award in 19 or 20 by GRI. So you can see the case study. It's available on internet as well. It's a very nicely energy management building.
Great. Mr. Shashidhar Dhareshwar is asking, is there any opportunity in the existing building to improve passive architecture benefits without much structural changes and cost effective?
It's a very specific question to like build what type of building we are looking for. Yes, we can definitely work on shading devices. We can definitely work on uh, ventilation system because as I mentioned earlier that I have recently shifted. I'm in the process of shifting to my new house. So I introduced stack ventilation into my existing house. So it was an old bungalow. Now I have shifted to it. So I uh, made some changes. So the old existing structure staircase was there with corrugated cement sheets. So I just removed those sheets, placed acrylic sheet with a turbo fan, And so there was a jali to my staircase, which was a cement jali. I removed that jali and placed a glass with the sliding windows so that the heat can be generated into that structure block, and a turbo fan was introduced. So it now that staircase is acting as a stack ventilation to my house. So yes, that it's extremely possible. It depends upon the typology and the what type of structure you are looking at.
Like you have removed that jali, existing jali, you have made your building sustainable, but you have created another waste. Is it not that?
It's a 30 years old building, 30 years old bungalow. So yes, I removed that. I have used that for the filling of my landscape area. I have not thrown it to any landfill.
Okay.
But if you see the longer run, then because my entire house is completely surrounded with trees, though there is a breeze outside, but because of the trees, the breeze is not coming into the house. So I need a draft. I need that draft to be created. That's why I have introduced that.
Sure. The next question is, will you please elaborate on inverted beam somewhere mentioned in your presentation? Inverted beam.
Okay, so usually, so what we have is a slab, and then you have a bottom, you have beams. So inverted beams are nothing but you have a slab below and you have beams above. So you have beams above. The best example is your water tank of your building. So if you go on the terrace level, so if you just enter to the terrace area through that door, you notice there won't be any beam. So there's a door lintel level, and then next is just your slab. There is no beam. So the your terrace water tank is a RCC. So that RCC wall itself is acting as a beam to that slab. That's why there are no beams to your terrace Mumty level where you are entering to the terrace level.
Okay. We have one more question. Integration of passive design strategies with Vastu parameters and whether it fulfills Vastu requirements.
Okay, so Vastu is nothing but purely science, and science is derived from Vastu. So whatever I'm doing since so many 15, 16 years, passive, and then I'm coming across with such clients who are asking for Vastu. So I realize Vastu and what we are talking in passive is it's a matter of just two different languages. By principle, it's fine.
Okay. One last question we'll take. Any preliminary check list you can share so as to consider during designing residential and industrial buildings?
Checklist for
Checklist for designing or checklist to consider during designing of residential and industrial
the
building.
extremely important thing is to understand the site context and the climate context of that city. Because in India is like a vast country where you have different climatic zones. You have hot and dry, composite. Every city, say 50, 60 kilometer radially distance if you go. So if I travel from Mumbai to Pune, I'm crossing three different zones from warm and humid to cold, and then Pune again moderate or warm and humid now. So every city demands different things. So the moment you change, the moment you change the city temperatures and humidity, ये सब अगर change होगा, so automatically your approach to passive features will change. So in a city like Nagpur where you required a evaporative cooling system, but I can't use evaporative cooling system in Mumbai because it's already humid. So it depends totally on the climate context. So understanding climate and site context is extremely important for passive design features.
So, we have another question about roof cooling, rooftop cooling. Can you suggest methods for roof cooling as maximum heat input from the roof? So this is the last question we are taking.
Roof cooling system. The insulations are there, but then if it's an existing building, you can have this cool roof paint as well, or to reduce the heat gain from the roof. But there are insulations which are available, but I don't want to use insulation in my building. So what I did is inverted uh, pots were introduced, which gave me a air cavity, which is the best insulation I believe. And a terracotta pots are very easily available. So that's my way of insulating the roof.
Okay, that was indeed wonderful question answer session. Thank you very much. We
Thank
have
you.
Gaurang Lele, architect Gaurang Lele with us. So he would like to, have his expert comments on your presentation. So I invite Gaurang. Gaurang, can you unmute yourself?
Hi, good afternoon. Am I audible?
Yes, sir.
Yes.
Yes, hi, congratulate. I would
Thank
like to
you.
congratulate Rahul. It was a really great presentation. You explained the case studies really well. This is a really interesting topic, net zero buildings or carbon neutral building, and it is the need of hour. So, yes, we all have to work towards it because we all have to reach that target of net zero by 2070. And buildings are major contributors toward all these carbon emissions. Definitely, like in small bungalows, in projects like you displayed or presented today, there are opportunities which architects, as an architectural fraternity, we need to work on. We have to basically work in synergy with all different aspects of building, because most of the time what happens is we architects design building, but we don't consider for climate, we don't consider for services, utilities, and during operation and maintenance of building, the major like when we talk about life cycle cost of any building, almost 80% of the life cycle cost is about operation maintenance period, right? So if we consider that operation and maintenance period while designing the building, then definitely we can address the issues related to operation and maintenance. Also, we as a fraternity and all stakeholders in India's growth and at the same time energy security, we all are energy engineers. We have to think about the mass housing and real estate, the way it is growing, what kind of materials we are using. Because when we talk about neutral, carbon neutral buildings or net zero carbon buildings, most of the time the embodied energy of materials. Like I'll give you example in Pune right now we are having like G+30 towers, which everyone is using with the concrete walls, Naivan construction, right? So we are consuming concrete and steel on humongous scale, and then obviously these concrete, steel, and other materials like glass are very energy intensive. So we all need to think about even those embodied energy aspects of building. At the same time, we have to focus on operation and maintenance of the building also. Yeah, so that's it from my side. I would like to congratulate Rahul. It was a really nice presentation. Thank you for your insightful presentation.
Thank you, Gaurav.
Thank you very much, Gaurang. I would now request our Secretary of Prerna Energy Professionals Cooperative Society Limited, Mr. Vilas Kulkarni, to give vote of thanks and his concluding remarks. And followed by that, we will have our 5 participants who would like to discuss about how this EKLS series has been so far for the last 1 year. Yes, sir, I'll unmute you. Yes, can you unmute yourself? Yes.
Thank you. आवाज परत दिल्याबद्दल. So this was a nice session, Rahul sir. I actually liked the short and sweet coverage of the topic, because the topic is so important and vast that covering it within 1 hour and 1.5 hours is difficult. But definitely your talk has increased the curiosity of the public, I think. So they will, the question and answer sessions showed that people were really enthusiastic to know this subject more and more. So our from Prerna Energy Group, our first sincere thanks goes to Rahul sir for taking out time and sparing to prepare this nice presentation, and giving a really interesting lecture on this topic. So the first thanks are due to him. The second obviously goes to our Gandhe sir, who is our chairman and enthusiastic. He is excellent enthusiastic person of all the Prerna group members. Uh, Always behind the Prerna energy related activities and works. So I'm thankful on behalf of Prerna to Gandhi sir. And obviously Asmita madam, she is our young generation and IT conversant person from our entire group. So thanks from Prerna Energy Group to Dr. Asmita. अशोक कुलकर्णी साहेबांचेही अतिशय आभार. आता आज हे नाही आहेत आपले शाळीग्राम साहेब, पण त्यांचे पण आभार मानायला हरकत नाहीत. आणखीन बाकी सर्व उपस्थित जे राहिलेत लोक, त्यांचे अतिशय आभार की त्यांनी आज जवळजवळ मला वाटतं 65-70च्या दरम्यान आज अटेंडन्स होता. सो थँक्स टू ऑल दी लिसनर्स आणि क्वेश्चन आन्सर्स ज्यांनी विचारले त्या सर्वांचेही अतिशय आभार. आय गिव्ह दिस सेशन बॅक टू डॉक्टर अस्मिता मॅडम.
Thank you very much, sir. Now we have few of our participants who would like to discuss about how the sessions were for last 1 year. I would like to invite Mr. R.V. Naisri. Naisri, sir, over to you.
Hello, am I audible?
Yeah.
Good afternoon, and thank you, Prerna and its team. It is this energy knowledge series was really an excellent one, and I really enjoyed. Every lecture, actually, I missed only one lecture during this 12 lectures, but all the performance of this selection of the topic, as well as those who presented, they were really good one. And right from beginning, say discussing India's carbon neutrality, then environment impact assessment, and other topics. Even this means my favorite topic is now green hydrogen and various colors of hydrogen. That topic was also discussed. And now you know there is one more color of hydrogen now added, that is white hydrogen or gold hydrogen, because it is natural hydrogen now. And then carbon footprint, and this PAT scheme by Milind Devre, and this member, this Santosh Gondalkar, who successfully completed this one commercial plant for this biogas, and he discussed his project. He first installed one this demonstration plant, and then now he is going ahead with the biogas. And now the biogas in India, it is gaining momentum, and so he has a lot of work to do. Then say one more topic, actually, India's energy transition in carbon constrained world by Ambassador Dinkar Srivastav. Actually, that topic was very interesting for me, because actually we are always considering that renewable energy is important and it is the solution for all problems. But there, this Srivastav, he discussed that atomic energy is going to play a very important role in this uh, particular means transitioning towards zero energy. So that topic was very interesting, and initially I was not very in favor of atomic energy or nuclear energy as for this to replace our fossil fuels. But then after reading through a lot of literature, I could get that this is one of the solutions and we should go for it. And with this commissioning of latest fast breeder reactor, I think this technology will be developed and will definitely adopt more this nuclear energy. And further, this whatever these topics were discussed on this COP28 by Hemant Pawar, or even Dr. Tanna Ghosh and Manoj Tilrande. They were very excellent, and I really appreciate that the Prerna Energy arranged such various topics which were of much interest for everybody. And I wish in future also, this next series will have more such very interesting topics to get information and further improve our knowledge in this various energy and environment sector. Thank you very much, Prerna and its team.
Thank you, sir. Thank you for the wonderful words. Now I would like to request Mr. Uday Kulkarni.
Yeah, thank you, Asmita. Very good afternoon to everybody. And first of all, sorry, I have to take this call from car, since being a very rare occasion of long weekend, I am on a family trip to some areas. But yeah, nevertheless, I didn't want to miss this opportunity, and especially when Gande sir, I won't call it request, but he can command it to us, right? So, first of all, thank you. Thank you very much, Rahulji, for your wonderful insights about this topic. It was really helpful and informative. One specific thing I would like to mention about EKLS, which I always look forward to attend every first Sunday of every month, is the diversity of the topics and the speakers. So we don't have only the technocrats or engineers, but we also have the participants like policy makers or diplomats who talk about different topics like energy efficiency, energy transition, renewable energy, and digitalization. So this depth and width of the topics really makes it very interesting. So, and again, I would like to thank Prerna and Gandesa especially for their commendable efforts for planning this series over the past 1 year, and the selection of the topics, speakers, and hopefully I'll get a chance to speak also sometime during this year. So really looking forward for that. And thank you and congratulate once again. Look forward to participate in more and more sessions. Thank you, Asmita.
Kulkarni
Thank
was
you,
talking
Uday.
from UAE. In that, he is talking from near Dubai. He talked to us from Dubai.
Yeah,
Live.
and that also yeah, sorry sir, that also reminds me one more thing. Why I look forward to EKLS is being outside from India for almost 11 years now. I think this kind of sessions also help people like me to keep updated about the policies and the energy scenario in India, right? Which is very close to our heart. So again, thanks for that, Abhi.
Thank you, Uday. We
Over to you, sir.
appreciate. Yeah. So now I would request Mr. Kumbhoshkar from Kirloskar Oil Engines Limited to please unmute himself and give his remarks. Mr. Kumbhoshkar is there? Okay, now Mr. Abhijit from Kirloskar Brothers Limited.
Yeah, hi. Am I audible?
Yes, you are.
Yeah, very good morning. It's good afternoon. Very good afternoon to everyone. So before I impart thanks to EKLS, I would like to congratulate Mr. Rahul for his wonderful presentation. And it took me for that era because I belong to Kirloskar Brothers and our corporate office. It happens to be a green building. It is a CI rated, platinum rated, a LEED certified building. So few of the topics were quite related, and we would like to invite you to our corporate office wherein we can get more information and more opportunity towards being more greener building. So thank you, Mr. Raul, for this wonderful presentation. It was a great presentation from your side. Coming back to EKLS, yes, I remember day one was on 7th of May 2023, where it was the first session. And from that, there were so many sessions. I think it was a ocean of collective wisdom. So this was really beneficial to all of our coordinator from where all of the plants and all of the location. And we took most of the benefits because most of the activities now SEBI is mandating towards the corporates or the listed companies, and most of the doubts were clarified during the course of the session. So it was very helpful session. So I congratulate the entire team of EKLS and special thanks to Gandhi sir. Thank you, sir, for such kind of wonderful session, and we would like to continue such kind of session henceforth also. And yes, Asminda, well coordinated, and you brought so many mentors and so many expertise under one roof. It was a tough job, but yes, you handled it very well. So congratulate to you as well. Thank you, and have a great day.
Thank you very much. Thank you for your kind words. Now I would request Mr. Ambedkar from KPCL. Mr. Ambedkar is there?
Yeah, madam.
Yes. Please go ahead.
Yeah, good afternoon, everyone. Yeah, it's my pleasure to give the feedback on the concluding session. I hope we all have enjoyed this session, and also I hope there will be more such EKLS session in the coming days. We have attended the various sessions uh, on energy knowledge like environment impact assessment and EC clearance in India. Then various colors of the hydrogen based on generation pathway by KPIT technologies. Then our fourth session was on carbon footprint, carbon neutrality, and the carbon market trading. Also, we attended this training on PAT scheme, that is perform, achieve, and trade, which was given by the Secretary of BE. We also attended the training on compressed biogas and the energy transition, also the energy sustainability and climate change, the role of UN Sustainable Development Goals, and building in the resilient futures for the humanity by Professor Prakash Rao. Also, we have received this updates on Dubai COPS 28 and super power of the IoT for the energy conservation was a very nice session. And finally, today's session was excellent. Thank you, Prerna Energy Professional, for arranging the EKLS session for professional life to us, those who are working in industries. Also, special thanks to Gande sir, Vilas Kulkarni sir, for arranging the sessions for the KPCL during Energy Conservation Week celebration in the month of December 23. That subject was on this energy conservation for the home and the factory. More than 78 participants from the KPCL has attended this training. And this was also nice training which we have arranged during the Energy Week celebration in the month of the December. So uh, this training will definitely help for us in implementing these ideas and the learnings throughout the sessions. Uh, thank you once again, and thank you, Prerna Energy Professionals.
Thank you, Mr. Ambedkar. Thank you for your kind words. We have a hand raised by Mr. Vivek Deshpande from Kirloskar Oil Engines Limited. I would just like to give him a
Smita madam,
yes, sir.
Umesh Kumar is not attending because his mother is unwell and he has attended in hospital. So Pankaj Joshi will speak on behalf of Kirloskar Oil Engines participants. So I request Pankaj Joshi to, yes, please. Thank you. Thank you, madam.
Mr. Pankaj
you can
Joshi.
speak.
Pankaj Joshi.
Vivekji is not there, I think.
He is there, but
okay.
Mr. Pankaj.
Hello.
Yes, yes,
yeah.
we can
Hello.
hear.
Hello.
Yes, go ahead.
Can I?
Go ahead.
Yes. Thanks for giving me the opportunity to attend this EKLS lecture, sir. I can give below feedback based on the common areas. The content and structure of EKLS series lectures are high quality. The engagement and interest of lectures engaging by incorporating interactive elements like discussions and real-world case studies. Visual aids and presentation styles are very good. Lectures provide sufficient depth of information without overwhelming the audience. Encourage the audience interaction and participation. Lecture content is relevant to audience interest and information is current with emerging technology on trends in energy. Overall, the EKLS series lectures that engage the audience, prompt learning, and encourage the active participation and discussion. And below topics, there are opportunity to implement idea in our organization. The carbon footprint, carbon neutrality, and carbon market trading. Second one is the perform, achieve, and trade scheme of BE, achievement and challenges, sustainable energy practices and their environmental impact, and superpower IoT for energy conservations. So I am very interested to participate coming EKLS lecture series. So thank you very much, Gande sir, Kulkarni sir, Deshpande sir, Asmita madam, and Rahul sir for giving me opportunity to on this platform. Thank you very much.
Thank you all
Hello.
for your kind words and expressing your heart out about this EKLS series. Now we would like to hear from our chairman, Mr. Gande. Gande sir, over to you.
Good afternoon, everyone. I think I must thank first Rahul for a wonderful lecture. I know him for since 2010. I just would like to share one thing with all of you is that even at the students while he was the student, he got the prize. That time I think in 2011. Institution of Engineers, where I was over there at that point of time, we had given him a prize for designing a 11-story building, without any air, air conditioning system. It was natural air conditioning. So he got the Energy Conservation Award, prize of institution for that particular design of the building. Since then, he has been performing extremely well. And of course, as you can see, he's a very, very modest person. He has got and not only his looks are philosophical, but his thoughts are also philosophical. And it makes us think. He has got a deep understanding of the subject, as you would have noticed. And I'm sure that we would like to have him more, because for some more lectures under the EKLS series. Thank you, Rahul, once again, and please be with us again and again. I thank all the speakers who spoke so well about the energy knowledge lecture series, about Prerna, about the speakers, about the topics. I think all of you, Mr. Nesriji, or Ramchandran Nesriji, Shri Uday Kulkarni from UAE, next from Dubai, Shri Pankaj Joshi, Shri Ambadkarji, all of you spoke so well about the energy knowledge lecture series. I'd just like to take only 2 minutes. I think all of you have already given a talk of what lectures were covered, which were the speakers, which were covered. I will not repeat all that thing. At the beginning of the series, we had promised that we'll have lectures from eminent people, renowned people. So we fulfilled that because most of the speakers, they are nationally known people. They are nationally reputed. Some of them are even internationally reputed people, and some are them from outside. So from UAE, Mr. Selrande was there, Nandan Pawar was there. So we made also fulfilled that promise that we will also get to speakers from abroad, and that is what our effort also will be for the future. So it's wonderful of for the Prerna to have so many well-known speakers giving lectures under this roof of energy knowledge lecture series. We are extremely thankful to all of them, though of course all others are not there, but I will convey to them our deep, sincere thanks to them. And they made the sessions very, very lovely. The question and answer session for all the lectures where it went from 20 minutes to 30 minutes. That shows the interest also shown by all the participants. I must also appreciate all our audience because and today was perhaps the peak was reached. We had about 67 participants. So I thank all the audience also to give support to our energy knowledge lecture series. We continue to deliver good lectures. I just want to inform our members that we have already prepared a plan of 12 lectures for the year 2024-25, starting from 5th of May, and we have another 18 standby lectures. 15 standby lectures. Also, we have identified the speakers, and we have also identified the topic. Of course, all of them will be time scheduled, but I can promise you that there will be similar repeated lectures speaking to us, delivering lectures to us on again diversified topics, because our participants also come from various fields. So naturally, we have to also ensure that we have topics from from various current as well as national as well important topics will be covered under this. So thank you all once again. I will request, of course, I will hand over to Asmita, but I will request some of us, including Rahul, to stay for some informal chat after our announcements are over. Thank you. Over to you, Asmita.
Thank you very much, sir. Thank you. So now we declare that this lecture is complete, and we would request all the EKLS, all the Prerna Energy Sources members and Mr. Rahul to please stay back. We will have just some discussion. Rest
I will
can
request,
log out.
I will request all the attendees to also continue, to attend our lectures in the next year. So, you know, most welcome to be with us throughout 2024-25.
Yes. So we had over
I
100
request Prerna members
participants.
to stay back for some time, five minutes, just to have some informal talk with Rahul, those who could not have a word with him. Anyone else also wants to talk to him can also still remain.